Okay, in this problem here, we want to find the stress in each member. And what I have here is I have a load that's being over this entire surface. The load is going to be 10 kips. You have three cross sections that are all at the same plane, meaning one's not below the other. This one has an area of 5.86 inches squared with an E value of 15 times 10 to the third KSI. This one has an area of 3.142 inches squared with an E value of 10 times 10 to the third KSI. And the other one has an area of 4.68 with an E value of 12 times 10 to the third KSI. And we want to find out the stress in each one of these members. Now you cannot just take the 10 and divide by each of these areas, because each of these areas is going to see a different load, a certain percentage of the 10 kips. So what we can do first is we'll draw ourselves a free body diagram of what's taking place. And what we would have here would be a vector coming down. And that value would be your 10 kips. I'll just make it 10,000 pounds. Now each one of these is going to be producing a load going back up, a force going back up. And we'll make F of A, F of B, and F of C. Okay, going to extend down a little bit. Then we can write the equation that the summation of forces in the y direction will equal to F of A plus F of B plus F of C minus 10,000 is equal to 0. Alright, obviously we cannot solve this with one equation, three unknowns. However, we do know this. We know the deflection at A will equal to the deflection at B, which will equal to the deflection at C. Alright, and we do know that the equation for deflection is just going to be PL over AE. Okay, so we'll go ahead and write our equations down. So using P, we'll use F of A times the length over the area of A, which was 3.142, times your E value is equal to F of B times this length over 5.86 times 15 times 10 to the third is equal to F of C times L over its cross-sectional area, which is 4.86 times 12 times 10 cubed. Alright, so let's scroll up and make sure we got those right as far as the areas. We have 3.142 for A, 5.86 for B, and 4.86. So everything looks right. Okay, what you'd want to do now is simplify as much as you possibly can. L's are gone, L's are gone, L's are gone. Now you can take out this too, because each have 10 cubed here. Just be careful, make sure they all do before you do that. So our equation is a little bit simpler. So what I would do at this case would be solve for in terms of what, shut this off real quick. Solve for FB and FC in terms of FA. So if we look at just this part right here, then we can say that FB is going to equal to 5.86 times 15 divided by 3.142 times 10, and then that'd be F of A. Again, moving all this up and just solve for FB in terms of FA, and we will get 2.798 FA. Okay, now you can do the same thing for FC. And if you run those numbers, you should get FC. It's going to equal to 1.85 FA. Okay, so now this problem becomes pretty easy because now all you're going to take is this and you're going to substitute it back in for FB up here. And grab a different color, and you're going to take FC and substitute it back in for this value right here. Okay, and let me extend down some more, give myself some more space. So then we can go back and say the summation of forces in the y direction will equal to FA plus 2.798 FA plus 1.856 FA minus 10,000 is equal to 0. When you do that, you will find that FA will equal to 1769. Okay, and then once you have that value, let me put that in pounds, sorry. Once you have that value here, just take it and put it right back into here to find FB. And take that value right here, put it back into here, find FC. Okay, now the easy part is to find the stress. Stress is going to equal nothing more than P over A, or F over A. So to find A, the stress at A, you would take 1769 and divide it by the area, which is 3.142. That'll give you stress of A. I won't run that calculation, I'll let you. FB, you take the load at FB, 49.58. You divide it by the area of B, and we say the area of B is 5.86. And last one, find F of C. Just take the load that FC is 3283.3. Divide that by the cross-sectional area of C, which is 4.86. And run those values and you're done. So again, not a bad problem. Again, notice when you apply a load like this and you have some type of plate that the deflection of all three of these have to be the same. Alright, best of luck.